Hi everyone, nice to see you. Welcome to week 4, right? Um, we're kind of past assignment 1 now, so you should all feel like you've gotten at least one milestone behind you, 15% of the course out of the way, which is good. And we're on to the next bit. So today, um, originally today I had a number of like little lectures planned, but what I've started to notice is that the number of forum questions have definitely creeped up in the last few days of people who are trying to get stuck into assignment 2, and because of that I thought, how about instead of today talking about some topics we were going to talk about, like some React topics and units and stuff, we pretty much just do a deep dive into what assignment 2 is, getting it set up, doing the basic interactions with it, so at least you have some like central thing here where you can be like, okay, this is how to get started. So today's lecture, as you can see it named here, is pretty much just let's have a look at assignment 2 together. This will evolve into a number of other topics, but generally speaking, it will just draw upon other things that have been taught. Now, one thing I will say is that, again, for anyone watching this live or anyone watching this recorded, all of week 4 Ajax, callbacks, promises, and fetch will be kind of assumed knowledge here, in terms of like there's an assumption that you've seen all of these, and if you haven't, I mean, you're not going to die, but I'm not going to be like answering the fundamental question of like what is a promise, because that has been covered in the lectures. We'll go into auxiliary stuff about that, of course, but that's why the lectures are here, so we don't have to double count everything. Now, first things first, let's have a look at the assignment. So assignment 2, this was released on Monday night, early Tuesday morning, and I think there may be some slight changes as we go. But in general, assignment 2. It's an assignment where we're expecting you to write a lot of vanilla JavaScript. So this is you building a little mini project. That's what assignment 2 is. The project's called Linked Pick, and it's basically a ripoff of Instagram. And what's happening here is that just having a glance at this. Normally, if you were to build an app for a spec kind of like this, you would probably do so with a tool like React, Vue, or in the past probably Angular more. Whereas what we'd like you to do is actually build this without one of these frameworks, primarily so that you can understand the underlying kind of mechanics and processes that power these tools anyway, because all frameworks do is allow you to write a more abstract program, and it kind of transpiles down to this anyway. And I was talking to a student about this a little while ago, which was like, it's like we teach at UNSW, we teach COMP6080, which is C, and then we also teach like COMP1521, which is, just some of the MIP stuff a little level under. So, and we do that because it's important to understand different levels of abstraction. If you haven't watched the week 4 lectures, like if you've kind of gone to all the, lectures 1, 2, 3, you've watched all of 1, 2, 3, and you've also gone to the week 4 shoot, then you actually have a lot of knowledge that you would need to start this assignment, because most of this assignment is HTML, CSS, a bunch of DOM manipulation, and then a bunch of network requests via fetch dealing with promises. And that third part is what's probably going to be newer to people as you tackle this assignment, and that's what's started to be covered in Zane's lectures, in some of the Grape lectures. I'll also just flag that I have generally been feeling physically a little off today, kind of just like tired and weak generally. So I apologize, I'm fine, but like I apologize in advance if I talk slower or seem more dead today. I think it's a fun topic today, but I'm not at my physical peak Not I'm ever at my physical peak, but you get the point. So, yep, we're building it like that. And one thing I think that's really critical to understand is that if you think about building a website, you might think of it as a series of HTML pages, right? Because I know a lot of people in this course have dabbled in this stuff before, and you might have a home page and another page and another page, and you might use JavaScript to do some funny things. But we're building what's called a single page app. And I think there's also another little lecture on this in week 5. So, I haven't assumed that you know it yet. But a single page app is... it's basically like to get back to the model of how websites used to work, right? Was like if this was like time, like if this was as time is passing for a client and this was a server, then typically what you would do, like this is like 15 years ago, right? Is a client would make a request and a server would give a response. And this response would be a full HTML page, which would be like HTML, CSS, and JavaScript. And that's what would happen. And you can kind of think about this if you think about, like Wikipedia is such a classic example of this because it's a fairly, old site. Whereby like with Wikipedia, every time you click on a page, you're sending a request to Wikipedia's servers and you're getting a response and it's re-rendering a whole page. And the easiest way to tell this is happening is to like watch the loading bar here. Every time I click, you'll see it's actually loading something. And when I click here, it's loading something and it's returning a whole new document. Browsers are very smart. And they're pretty good at like doing things like, notice sometimes the page flashes and sometimes it seems like just part of the content changes. The whole page is actually being reloaded on these websites. It's just your browser is able to kind of notice that difference and kind of quickly be like, oh, let's keep these components here. But that depends a bit on the network connection and other things. But you can see they're all new pages. You're getting the separate page back every time. So, it's just this it's just like this process here on repeat and then on repeat many times. Now, what often happens with modern web applications, though, is that you don't really do that. You do a thing where you make a first request to load the initial HTML, CSS, and JavaScript, which is made by the browser directly, typically by you clicking a link or something else. And then everything after that, you tend to make API calls. And then you tend to get a response from the server that will often be a whole bunch of data, typically something like JSON. And what happens as part of this is that like classic websites are basically a series of templates and files that web servers are just giving back to clients. Whereas in modern web applications, you can actually build pages with your browser. And you know this because you've done this with some of your tutes or labs where you actually build whole components and form elements and append them, right? You can build pages just on the front end. In fact, you don't even need a web server most of the time. You could just have a JavaScript file that's loaded once and then it could just be totally dynamic and like load the page a whole bunch of times. And you can actually, you find this with simple games like, I don't know, like free Tetris, right? This is an example of a game where largely this is somewhat serverless in the sense that I'm trying to monetize. Good for them. Where a web server has to load the initial page here, right? To actually load all of this. I hope this isn't a Flash program. If it is, I'm pretty sure it's not, but let's pretend it's not. If it is, it's like all of this that's happening here is happening with JavaScript. You could imagine that this is happening, right? It's all just a whole bunch of like add event listeners and key bindings and then like timers that are moving things down like this, interacting with the browser. If I disconnected my internet here, this would probably still work. And this would work until a point where basically, right, I needed to contact the server somehow. And like, why would I need to contact the server? Does anyone have any ideas? Like, what's something you would need to contact the server for? Well, maybe saving something. Like think about it, right? A server's there to kind of exist beyond the lifetime of your browser, right? Because your browser might disappear, or you have to refresh or restart. So saving things, or maybe getting some extra data, multiplayer, all of these things are where you actually need a server. So if you kind of picture the web instead as a way where you load your initial resource, you try and do as much as humanly possible on the front end, right? Why would you do that? Because it's powerful. It's like you don't have to talk to servers and deal with networks. Most modern computers are pretty performant. They can just do stuff internally. But when you need things from the browser, rather than sending a whole new request to get a whole new page rendered, you actually just send a little call to some kind of API where you get back some data and then you can do something with it. For instance, if a user says load saved game, right? That saved game's probably not on the client. It's probably on a server somewhere else. So you click load saved game and your browser will send a request quietly in the background to a server, which you'll get a response. And then that response, just like a normal, data object in programming, you'll use that to actually populate something. And this is how we actually start to form these ideas of single page applications, whereby you have an initial load, and then everything that kind of happens after that is just a series of API calls quietly made in the background. And that's what we're building here. So we're not building a series of HTML pages. In fact, your entire assignment is just going to be one HTML page, a super dynamic HTML page, where all of the dynamism is essentially brought in by the JavaScript that you write. Now, before we get into the front end, I'm going to jump to section 3 and talk about the back end, because I think that's slightly more relevant here. You are building a front end. That's what this assignment is, and a back end is provided to you. So you are given a back end. There's no back end coding for you to do here. But if we look at the back end section, you can see that we don't include it in your repository because it's big. I don't know how big it is. It might be like 10 megabytes or something, and it's like, deploying 10 megabytes to 300 students is just another 3 gigabytes sitting on CSE servers, right? Or if it's 50 megabytes, then it's, a dozen gigabytes. But so we've got it in this other backend repository here. So let's say you're starting this assignment. You're going to go up here, you're going to clone this. I might do this locally today just for fun. I'm using Windows Subsystem for Linux, which is probably the most stable thing you'll find outside of actual Linux. And I will create a new folder called assignment 2. I'll go inside assignment 2. I'm going to git clone that to this folder. So I'm cloning assignment 2 to this folder. You'll have a different repo link, obviously. And yep, you can see, I don't know how big it is. 10 kilobytes is the whole assignment, it looks like. Yep. Great. And then I'm going to clone a second thing, because this is my actual assignment, but I'm going to clone a second thing here, which is the backend, which is a second repo. And this is a repo everyone shares. You can't push to this repo, but I will clone this in another folder. So I'm going to make another folder called assignment 2 backend, which I've already added. Oh no, it's because okay. I'll just call it assignment 2 back. I'll go inside assignment 2 back, and then I'll git clone that here, and we'll see how big this one is. It's probably not massive. Yeah, 7 meg. I was probably being a bit... Well, actually, the main reason we don't put this in your repo is because you don't change it. If there are problems with it, we just update it and ask you to do a git pull, and there shouldn't be ever any conflicts. So it's just easier to kind of do things this way. So we've got this backend, right? And this backend repo that everyone shares, this is what will power the front end that you build, right? So this is a web server that is already built for you. And let's actually have a look at this web server together. So it says how to start the RESTful API server. Steps to complete once. Only complete these steps once. Clone this repository somewhere. If you aren't on the CSE machines, you may have to install stuff. Okay, I'll try and install these two things. Obviously on my own local machine here, I should probably do them one line at a time. On my own local machine, I have installed these before. So it's just going to say they're already installed, but like just going through the motions with you, I copy and paste them in. Yep, great. And then it says within your backend folder, So as in, I have to be inside my arst2 backend folder. I can't do this somewhere else. pip3 install-r requirements. Now, a number of students have said that they get some errors with this stuff. In fact, I might even get some errors with it. Yep. So in general, most of the time, if you get errors here, that's not going to make or break things, and you should just continue like normal. The golden rule is that if you can run the backend, it's fine, right? Like, you shouldn't be concerned by errors on the installation. Just be concerned by error, like if in some way the backend crashes. If the installation doesn't work, you will notice it because the server simply won't function. You're not going to like have something that appears to function but is actually broken. So you don't need to stress about that at all. So I've done that step. I've done that once. And then it says running the server. To run the server within my backend folder, I run python3 run.py. I'm going to hit enter there. Okay, so it's running. Great. That was super easy. On VLab, you don't even have to do these two steps here. You literally just have to do step 1, step 2. And you have a whole backend running. Now, running it is very different from understanding it, right? Understanding it, you know, you have to think a bit more. But let's go back to our main assignment 2 repository here, where we actually can see what we're doing. So the backend server is not part of this, blah, 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 blah. You can access it here. Clone this repo, git clone. Once cloned, view the README to see how I get it running. 2 steps ahead, the backend server will be where you'll be getting your data. Don't touch the code in the backend. Although we provided the source, it's meant to be a black box. As in, like, you can actually change it because, like, we've given you the source code for it. But just don't touch it. Unless you want to. I mean, if you want to, you can. It's just like, you're probably going to break something if you don't feel confident with what you're doing. And the other reason to not touch it is because when we test your stuff, we will be testing it out with a clean copy of the backend, right? Blah, blah, blah. For the full docs on the API. Now, just before I finish the sentence, this is critical because you probably are like, what, you know, this whole thing about like, what's an API? And like an API, all an API is in a modern sense is in the most common use case of it, it's a web server that's running. It's a backend that's running on a web server that's accessible on the internet or some kind of network where you can call URLs with some data and you'll get some data back. And typically those URLs are done sending data with JSON, the data transfer language, or the data, whatever you will, like one of the universal data languages. And that's all they are. If you actually think about them, like APIs are basically just sets of functions. They're just sets of functions that happen to be on the internet, right? Like you're all used to sets of functions. Like if you've used Python, you're used to like the math library, or NumPy, or the datetime library. If you've used JavaScript, you're used to other kind of libraries that you might import, which have different functions in them. An API are just functions, i.e. they have parameters and they return outputs. It just so happens that they are often web-based and accessible on the web, right? Now, for the full docs on the API, so the API, the term API here is being used interchangeably with the web server, the backend. Start the backend server and navigate to the root URL in a web browser. Very likely to be localhost 5000. Okay, let's try that. So I'm running it. Yeah, I did that already. And it says navigate to this URL, paste. Okay, I'm zoomed in a lot here. But it says API version 1.0. All right, seems kind of underwhelming. Lots of scary information there. I expand some stuff and I see lots of stuff here. Okay, so what am I looking at here? I'm looking at a web API. There's actually tons of these all over the internet. One of the first APIs I remember ever working with was a long time ago, probably like 6-7 years ago now, which was Stripe's API. Stripe's a payment gateway. It's one of the most popular credit card payment providers now. And, you know, it was basically a... sorry. I'm trying to see where there's some good... Oh, yeah. You can actually see it here on the right-hand side. Yeah, Yeah. Yeah, so you can actually see similar things here. So have a look at the similarities between something like Stripe's API, where you can see that they've kind of got these like charges endpoints where they've got these like half URLs and then post get, and then if I go further down, there'll be like these like report types URLs where it's like get and post get, delete, and some other half URLs. So you see they're actually kind of the same thing here. So you're working with a fairly standard format that you're going to come across. Like many of you will come across this in your careers in some way. And what are these things? Well, what these things are is these are saying that if you make a request to one of these URLs, right, like post/get, /post/, then you will get something back. And there's a lot of kind of complicated, interesting instructions here. So a few things to unpack first. The first one is, whenever you call these APIs, you are basically universally calling them on the same URL. So remember how I loaded up these API docs on like localhost 5000? Well, when I'm talking to this post thing here, I'm literally just accessing the URL /post. And when I call post unlike, I'm just accessing the URL post unlike, like this. Okay, I'm just calling those URLs. Now, that should make sense to you all. One of the things that's probably confusing though is all these different colors, right? Where you've got the post and put and get and delete. Now, the thing about post, put, get, and delete is that these are just descriptors that help people like you, developers, understand what type of request you're making. These don't have any inherent meaning to computers, really, like as in you having a post request does not constrain you in any way. It's just the type of request that you're making, you know. It's a little bit like file types on a computer. Like when you have a file type on a computer that's like mystuff.txt, this .txt doesn't mean anything. It doesn't change the contents of the file. It doesn't stop the contents of the file being of a certain type. It's actually just a helpful instruction so that computers can help better categorize things, right? Have you ever noticed that when you go to open an Excel file and you look in a folder, it only shows you all the Excel files to open, and it knows they're Excel files not because it scans the content of all the files, but because all those files end in like XLS or XLSX. So it's the same kind of thing here with delete, get, put, and post. So these are what we call HTTP methods. That's what get, put, post, and delete is. And they're quite simple because post is you saying I want to create something, put is you saying I want to update something, delete is you saying I want to delete something, and get is saying I'd like to read something. So you can actually piggyback on these understandings because post here, you know now that this is saying I would like to make a post. Create a post. Get is saying I'd like to read posts. Delete is saying I'd like to delete posts. Put is saying I'd like to update a post. So the semantics of these HTTP methods will dictate to you what these particular requests are doing. And we'll get into a practical example of this soon. But if you actually click on one of these, you'll see that for each one of these API routes or API endpoints, and those endpoints are defined by URL and an HTTP method, it gives you a description of what it does. It also then tells you the parameters that it expects to give the server, as in these are like, you know, function parameters, and then it tells you what you will get back, like the response. So you know how when sometimes you write coding comments, you'll be like, these are the inputs and these are the outputs. It's the same thing here. It's like, you know what, this here post is a function, this is a description, these are the inputs, these are the outputs, that's everything. Now there's a lot to HTTP that you'll kind of have to pick up on as you go that isn't super critical, but that's the crux of it. That's the basics of this whole thing. Now, yep, any questions so far? It's probably a good point to ask people for questions. I'm not going to go through too much of these details of this until we look at the practical example, because otherwise it won't mean a ton to people. Logan says, do we need to fully understand how the backend works to finish the assignment? That's a good question. So the best answer I can give you is that you need to understand how it works behaviorally. But many things are like that, right? Like to use VS Code, you have to understand how VS Code works. You open it, you open a file, you can compile with it. But you don't need to know how it's built or why it's built a certain way or what programming language it uses or anything like that. So you do need to fully understand the backend to finish the assignment, but only at a behavioral level. And what I mean by behavioral level is the only part of the backend that you ever need to interact with is this web page here that you can access when the server runs. Because you need to get familiar with like how this actually operates and like, you know, when you pass something in, you'll get something back. But you don't really need to be concerned with the fact that it's built in Python or that, you know, there's a certain type of database powering it. That's all implementation details. So you basically need to understand it like it's a black box, right? That's it. You just need to understand it like it's a black box. And I always have students, last term I had some students kind of be like, why don't we have like a 1 hour explainer video about how all these different endpoints work and like, you know, all the examples for it. And I mean, the kind of answer to that, because I'm sure a couple of people will be thinking this, is like, it's actually really, really normal for you to work with systems like this where you don't fully understand it. Like, if, like Stripe's APIs, right? They're not straightforward to understand. Like, I work with a lot of APIs, and there's always like a ramp up period where you just kind of have to poke it and prod it and be an explorer and try and get a sense of the behavior of them and then connect dots and be like, oh, okay, I get that. And I've already seen people making forum posts about it, which is good. So you do have to understand it just at the black box level. And part of the understanding process will always be you poking around and trying things out. We will talk about it a little bit though. Okay, let's move on. Ive says, but what if you have a limited number of API credits where experimenting with an API would require wasting those credits? Usually most APIs will give you test credentials. So, you know, usually they won't be metered. Hong Tao, if we don't cover this in the lecture, then just post in the forum, but I usually don't make a habit of debugging things in a lecture, if that's alright. So let's play around with it. So let's keep reading. Please git pull on the backend server at least every couple of days. We will no doubt be pushing fixes and clarifications. I don't think that'll happen massively, so I don't think you need to worry too much about that. You know, though, usually if we push stuff, it's because it's broken and we'll pin a forum post about it, so I wouldn't worry too much about this. Okay, and then the last section of the backend, last part of the backend section is saying that if you're comfortable with basic SQL, in the assignment to backend folder, which is this folder, it says that there is a file db/test.sqlite. So db, okay, we have this test SQLite. If I try and print that out, I get an error. What they're kind of saying here is that you can actually go to this URL. There's a few other of these, but if you go to this like URL like SQLite online here, if you actually grab that folder from your file system, this test.sqlite3, let me just open it up. Two seconds. There's the file. Okay. Oh, maybe it's changed. Ew. Sorry, I just have this up on another screen. It's giving me grief. This wasn't giving us any problems. Okay. Maybe it's fine. I'm worried. Memory access out of bounds. Oh, that's not good. Okay, I'll have to fix that up, but... that's a shame. I wonder why that doesn't work. 2 seconds. Maybe I'm not giving it the right encoding or something. Oh, CSV, SQL schema. Maybe that was the problem. So I just tried changing this from CSV to SQL schema, though I'm kind of dubious about all these. Maybe I should be doing like file. Oh, OpenDB. Okay, I was trying to import something. Sorry. So importing, I think, is expecting like a CSV or something, but I'm doing OpenDB. I still got a table index out of bounds here. OpenSQL. Maybe that's what I need to do. Sorry, I just make a habit of opening files off another computer because obviously I'm doing everything on my personal computer. Okay, that still didn't work. Alright. I don't know. Let me, I think I'm having a bit of a moment here, but, so weird. Okay. Anyway, this step isn't particularly critical, but basically the web server has a whole bunch of, data in it. And one kind of common question we got last term was students saying, even though I know I don't need the data, because it's a black box, I'd still like to kind of see what entries are in there. Because the database we give you is pre-populated with like a whole bunch of usernames. So this backend is basically a backend for an Instagram-like application. Right, and I'm sorry, I'm just trying here quickly to download something that will let me see it fast. 2 seconds. Oh, it just worked. What did I do? I don't understand. Anyway, I just went File and then I went to OpenDB. That must be crazy. And then I just picked this database here, which is inside your assignment 2 backend folder. I just picked that one. And it just loaded up like that. And it loaded up on the side here. It just said these like 3 tables. So you can actually see that there's 3 tables in the database. And when I click on these, if I want to explore them, I can just right click on any of these tables and I can click select show table. And it will show me stuff in that table. And you can see that, like, so again, I mentioned that this is kind of like an Instagram ripoff, and you know, many of you are Instagram users. I'm not an Instagram user, but I understand that it's kind of like Facebook except with photos. I know what it is, but you know, you don't need to know what it is my point. And you can see that the entire system is made up of users, which makes sense because there's users of a product. It's made up of posts, which makes sense because you make posts on tools like Facebook and Instagram, LinkedIn. And then there's comments, which makes sense because posts are going to have comments. Now, again, you don't need to understand the internal structure of this, but the reason I kind of flag this is because there's actually a whole bunch of data already in here. So you see that there's some post data that already exists, and they're all made by different kinds of users. So you see that, like, this is post ID 1, it's made by Sebastian. This is a description of the post. This is a published timestamp here. These are the likes it's gotten. This is a thumbnail image. This is a source image. These are some comments, blah, blah, blah. And then for users, I have, you know, Sophia, the username, name Sophia, password's cluttered. The email is sophia@email.com. They have a current token, whatever that is, and they have a following column. And, you know, all the data's here. So, again, the most you need to do at the back end is understand the API, but you can also, if you want to kind of see some of the data that just exists in there in a raw form, you can easily go to a website like sqliteonline.com and you can just like open the database there and have a click through it. It's very, very straightforward. Yeah, that's about it. So the reason we introduced this last term, this section, was because one problem like that students ran into was that when you're building a web application, you, like on the front end, it was like you kind of have to build the registration first, actually sign up a user, and then you have to have a user be able to be logged in. before you can ever have them make a post or view posts and stuff. But because we already provide some data with this, we wanted to give these instructions so that students would feel more comfortable being like, well, actually, there's already these users that exist that have already made posts, so maybe I can do the assignment not in like a linear order. I can actually kind of do things in an order that suits me a bit better. So that's why we did that. Anyway, we'll come back to that section later. But now we've talked about the back end, so that's the back end. Back end's all done. What is the front end with this assignment? Okay. It says that our front end is here. So I've got this folder here on the left, which is the front end, and it says stub code has been provided for us to get started in these files, and I'm going to have a look. So in my assignment 2 folder, it says I've got frontend/index.html. Okay. That looks like a pretty basic page. Frontend/styles/provided. Okay, I've got this files provided. Okay, some simple CSS. Frontend/source/api.js, helpers.js, and main.js. Okay, I've got these 3 files here. Okay, pretty short files. So this is like the starting code that you get. You can modify or delete the stub code if you choose. It's simply here to provide some help. Exactly. So you can actually get rid of all of that. The source folder, the styles folder, and the index.html. If you wanted to rewrite those, you could. Now, how do we run our front end? Well, from previous classes and everything else, you probably know from what we've talked about, like if you want to run your front end, you go into your computer, you open your CS6080/assignment2 file, and you drag the index2 into your web browser, and then you load up a page like this. This is this page, right? Index.html. And I'll prove it to you because I forgot to change. I even forgot to change the name of the assignment from last term, which is silly of me. Because we've already released it now, so I'll probably just have to change that back, which is dumb, but that's okay. We all make mistakes. So this like linked pick assignment, quick pick, it's all the same thing. The names are just there to like, so we can distinguish them, different terms, because we tweak things in different ways. Whatever the assignment is, it's like, here's a web page. Now, one of the problems that we'll get into, maybe today or maybe another day, is that it's really hard to talk to web servers when your web page is just running in a browser as an HTML file. There's some complicated reasons for that. And I'll perhaps try and show you here, just as a quick demonstration. And I'll do that by, before we even get into this. So let me jump ahead a sec. We've given you a front end, we've shown you the back end and how it's finished, and then this entire assignment is just doing a bunch of stuff. Right, section 2.1, 2.1.2, 2.3, like all of this here is the actual assignment. And it's just a whole bunch of to-dos. It's like, make it log in. So when a user isn't logged in, they see a page that gives them these fields, and when they submit the button, if the fields, then they call a thing, and then once the user's logged in, they should be able to see the feed which says not yet implemented, right? So it's like a whole bunch of instructions. That's the assignment. That's all it is. It's like, here's the front end, make it do this. And we've given you a back end to actually power it. So I'm not going to get into much of this today because that's the actual assignment, and I can't really do that for you. But what I will show you is like some basic interactions with the back end. So let's say I want to write the code that helps me log in a user, right? Now, how exactly does this backend work? That's kind of something we need to keep looping back to. We saw we had this API here. The first thing to note is that this dummy stuff you don't really need to worry about. I probably wouldn't worry about it if I were you. I'd focus on these 3 things. And you can see here that the main functions of the application, the server, are that there's some authentication services which allow you to log in and register. There's some user services that allow you to kind of get some users and post on their feed, or like follow and unfollow other users. And then there's some post services, as in like making a post on Instagram services, where you can add a post, delete a post, comment on a post, like a post, unlike a post, and everything like that. These are all the different capabilities. The thing you'll notice is that on pretty much all of these endpoints, they will all want and take in different things. You know, like delete post expects the ID of the post, and get post expects the ID of the post you want the information of, and post expects a whole bunch of information to do with like what's actually in the post that's being created, and update post requires the same thing. Post comment requires like the comment that you actually want to make on the post and the ID of the post. A lot of this is very self-explanatory. Like and unlike requires the ID of the post to like or unlike. The one thing you'll notice though is the thing all of these have in common is an authorization string or token. And the reason for this is because when you're on a website, right, and you've got your front end over here and your back end over here, the back end is just a server sitting on the internet, right? It's just sitting there. It's capable of like, how would you say? Like it's capable of accepting requests and giving responses, right? Like it's like, give me some JSON data and I'll send you back some JSON data. But the problem is that how do you know, like, if a random user on the internet just called your server and said, hey, I'd like all of the user information for a user ID with this username. It's like, how do you secure that, right? Like kind of basic security. It's like, how do you make sure that that person who's asking for that information is allowed to see it? How do you know they are authorized to see it? And the answer for that is you give users some kind of access token. Some of you might know this as cookies. I mean, access tokens can be stored via cookies, but it's kind of like, I think of it like a wristband, right? Like when you go, or other kinds of, if anyone's ever been to a hospital and you get like a wristband put on you or something like this, it's like, they ID check you when you come in. They look at your Medicare card or they look at your driver's license or your passport. And that's the point where they're like, yep, this is Hayden. We have determined and authenticated that this is Hayden. And then they give you some kind of authorization method so that it's really quick to, for you to be able to like be verified that it's you as you go. And also so that you don't have to like keep showing your driver's license all the time. Like that's what these authorization methods are. So when someone logs into a website or registers, they tend to enter a password. That's like showing your ID. And that's when the server can kind of say, yep, I know it's you because you've entered your password. And then what the server gives back, right? So you kind of give your password here. And then what the server gives back is it gives you a token. And this token is like that wristband. And that's what you carry around with you. And whenever you're a user on the website, every single time you do something like you ask for user information or you make a post or you like a comment, you're sending that token to the server because that's how the server knows it's you. Because if you didn't need to pass in that token, then basically the server, like anyone calling the server with any information would be allowed to do anything, right? It would be like totally unsecured. So that's one thing we're going to talk about today is this like little bit of a token. James, I don't know what you mean. What is that? Are you talking about something on my screen? You just like asked me what the Apple option key or whatever it is stands for. Oh, this is just backend. This is just a B. That's all this is. It's hard to write because my mouse has a very high DPI on it. So front end and back end, that's how those things work. That's why you'll see all of these requests for user and for post. They all require a token of some sort. So the most basic thing I want to show you today is how to log in. I'm not going to show you how to sign up because you'll be able to figure that out yourself. But like, how do we log in? So let's have a look at this post route here. Log in. This is used to authenticate a verified account created through sign up it returns an auth token which should be passed to subsequent calls to the API to verify the user. Okay. The request expects this kind of data to be passed to it from the front end. So parameters are what front end send to the server, and then responses is what the server sends to the front end in response. So basically the server requests to get a username and password, and then the server gives back a token. Pretty straightforward. Now, how do we talk to the server? Well, let's load up our page here. And what I'm going to do is, you see here they've got this like source/main.js. Well, I'm going to go to main.js, and I'm just going to sanity check that I can make this stuff work. I'm actually going to delete a bunch of stuff here for now. I'm just going to console log hello and see if my like code actually functions, because I don't understand what's happening yet. So I'm going to open the console. Yep, so it's already happening, which is good, because I wanted to kind of show everyone this, which is sometimes you'll see that some weird things happen where you'll see this terrible word called cause. Now cause is the cross-origin, oh god, what is it? Cross-origin restriction or something? Resource sharing? Cross-origin resource sharing. And I have a lecture piece that I might be able to find a link to it if you give me 1 second. 2 seconds. This is one of the things I was going to like formally go through today. But there's actually not much to it. It's not like a proper topic. It's not a thing you need to study. It just helps you understand the assignment. So, cause is a complicated set of policies and protections to ensure scripts loaded into a web browser don't call servers they're not meant to. Okay, sure, that makes sense. And this slide, there's really nothing to it. But basically what happens is if you have a website, right? And your website is, say, google.com. Most web servers by default, the way that they work is that when someone sends a request to them, they want to make sure, like for like API calls, that that request is coming from a browser page that is on a google.com domain. This is the server. And what I mean by that is when you open google.com, this page is going to be sending API requests to google.com when you do stuff, right? Like watch this, like autocomplete. Right, autocomplete doesn't just happen on the browser, because Google needs you need to send Google what you've started typing so Google can send you back the rest, which is like UN. See all these requests that are happening here? Every time this little search thing appears, that's us sending requests to Google where Misseng, Masters of Systems Engineering, cool. So every time we type something in, we're getting like these requests. This is like an API. This is what I'm talking about. These are single page applications. We're not refreshing the browser. We're just sending these requests to the server, etc., etc. But the reason these requests are succeeding are because I am calling them from a page that's on google.com. And you see these requests here. In fact, I could get the URL of one of these probably. Here it is, request URL. It's this URL. But what happens is if I started an application, you know, like my assignment 2 in 6080, and I tried to call this URL, what Google would do is Google servers see that URL coming, and they see that it's coming from, you know, haydensmith.com or something else, like a non-google.com site, and they block it. And that's how it's kind of it's a security policy in a way. It just basically makes sure that random people can't call your server. This is different from the login thing, right? The login thing I mentioned with the token is saying that for people who can call your server, it's making sure that authorized people are calling the right things. Whereas here what we're talking about is essentially stopping malicious people just randomly building a website that just tries to access the API of a server. So it's a simple way that they block people out. One thing that browsers tend to do, which is quite interesting, is that when you try and make an API call from a browser, and your browser is just loading a file onto your web browser, most servers will reject that, right? So what's actually happening here is that my web page, which is just an HTML file, is can be like trying to talk to the server, which it's also not running, but that's... Oh, this is even less. My HTML page here is honestly just trying to load source/main.js, this file here, right? But the browser is like not having any of it because it's really confusing, and it's confused because I'm running this as like a just a file. So when you do assignment 2, what you actually want to do, and this is written in the spec, is you load up your assignment 2 page, your folder, and instead of loading your HTML file directly into the browser like I've done here, you actually run Python 3, which is the Python interpreter, -m to say to run a module, and then you give it http.server. And what http.server does is it actually packages up your entire directory that you're in, and it serves it like it's a website. So you see this will run here, and it says that I have now started an HTTP server at this URL, and when you go to this URL, or it might need to be 127.0.0.1, yeah, it'll need to be 1.27.0.0.1, it actually loads up the page, because what it's doing is it's actually serving files from that folder, right? Because a lot of very simple web servers are literally just exposing a folder on the computer to the internet, and that's what's kind of happening here. I'm not saying we're exposing this folder to the internet, but now our browser, instead of just trying to load a file in our computer, is actually sending a network request to a web server that's running with Python, that's actually loading our files. So when you run this assignment, it's kind of like you run your web server in one terminal, like this, and you run your backend in another terminal by running the commands that we mentioned here, like that. And now you're running both, right? So here's my front end running, and then my back end's over here, which we're not interacting with yet, right? And that, like, so just to be clear, we've set up everything now. We're set up for it, and I'll show you because I can console log hello here, and when I open the console, we will see hello appear when the page loads, so everything's fine. Any questions about that? Otherwise, we'll take a break, and then we'll actually get into doing some coding, getting the front end talking to the back end. Ive says, just confirming from the start of this assignment, we need to have both the front end and back end operating. Probably you could do, yeah, you could kind of do some stuff without the front end running on the back end running, but generally I would have them both. Well, I would probably have them both from the start. Yeah. You could maybe do a little bit, but like, you know, if you're going to have to set it up anyway, you might as well get going with it. Cool. Okay, I'm going to take that as there's not a ton of questions. So let's take a 5-minute break, or 5 or 6 minute break. Come back about 7:06, 7:07, and then we'll get stuck into actually writing the JavaScript to talk to the server, which ties into the week 4 topic. So sounds good. Chat in 5. Hey everyone, welcome back. I don't know, I really was enjoying that hold music for some reason. Maybe I'm tired. So let's get into the coding part of this. So, we'll talk about marking criteria toward the end, if that's all right. So I want to show you, I want to demonstrate to you, like I've got this front end running here and this back end running here. And again, remember that the front end running as a web server doesn't mean anything. It's literally just like an abstraction of your file system. Whereas the back end running a web server is an actual like programming system. So if I want to communicate and I want to try and log in, this is what I would do. And I'm not going to write perfect code in these lectures because I don't want to take away all the challenges from you. But I have my API over here and I want to call the login thing, the login route. So here's what I will start doing. We'll build this out slowly. So one of the most basic functions built into JavaScript, I don't know which version, if it was ES5 or ES6, is the fetch command. And the fetch command takes in a URL, it makes an HTTP request to that URL, and it gives you some kind of thing back. So I'm going to put in the URL that I'd like to fetch to, which is localhost 5000 /auth/login. And I'm going to say const result equals that, and then I'll try and console log the result. Now this probably won't work, but we can try it out anyway, right? So this is us starting to try and make an API call to the server. I refresh the page, I look at the console, it says promise pending HO405 not allowed. Okay, well, forget the promise part for a sec. Why am I getting 405 method not allowed? So a 405 error, because you have all the HTTP status codes. These are all the different codes that a server typically responds to you with, right? And we've gotten a 405. So 405 means the request method is known by the server, as in it's like I think that's valid, but has been disabled and cannot be used. For example, an API may forbid deleting a resource. Okay, so what's happening here is that I'm trying to make a post request, or I'm trying to make a request to a post endpoint, but for some reason the server is not understanding that. It doesn't realize that I'm trying to do that. Familiarizing yourself with these error codes in general is usually good. Some of the key ones that exist are 200 OK, which says that everything's fine. As well as 400, which says that there was like bad data passed in, 401, which is kind of, if people pass in bad tokens, 404, which is kind of like page can't be found, right? So the problem with just the fact of fetch is that the way fetch works is by default, just like a web browser, all of the requests that it makes are GET requests. So I'm going to Google fetch post request, and I'll probably get a simple code example that I might be able to lean on here. So if I just search for post, and I have a look here, it's a bit hard to read because of the syntax highlighting, but you can see someone's actually using a fetch, and they're passing in not just the URL, but they're also using with this brace syntax here, they're passing in a method post. So when I call fetch, I don't just give it a URL, but I can also give it some kind of object where I say that the method is post, like that. So now let's try and use that. I refresh the page, and I get 400 bad request. Okay, so remember how we talked about error codes? Bad request typically is telling me that it's like a valid route. It's the server understands that I want a particular resource, but I have not I've not given it the right information. There's a problem with what I've given it. The other thing you'll notice is that, notice how it prints out this promise pending, and then it prints out this error, and you can actually see it happen in real time. Promise error, like they don't happen instantly, they happen like that. And this is because this comes back to the whole promise lecture, which you all really need to have seen, which is to remember that many functions in JavaScript are asynchronous. And what that means is that when I do line 5, 6, and 7 here, and I call fetch, JavaScript does not wait at those lines like it does in Python, C, and most other languages for that fetch to finish. It does not sit there and wait for that data to come. It keeps going. And once that fetch is finished, it'll process maybe callbacks or something else. And the way we deal with these things in JavaScript is that result here is a promise. So I'll say like end of code. Now, if you've seen Zane's lecture, you'll know that the way promises work is that this fetch here returns a promise, which is executed. And then after that, I say .then, where I use the response like data here, and I console log data. So again, just to trace back through this, when this code is run, this block of code is executed. The fetch call is processed. It's a promise. So the code keeps executing because it happens asynchronously. The code keeps going down. It console logs end of code. Sometime after it finished all that, the fetch promise like resolved, as in it got the response back from the server, and then the JavaScript engine executed the .then part. And the .then part is saying that here is a function, because that's what this is. Like this right here is a function. I could put brackets around this. This is a function that is executed with the result of the fetch call whenever it's done. If the fetch call takes, 3 minutes to run or 4 minutes, like it wouldn't take that long. If the fetch call takes 3 seconds to run or 10 seconds to run, then this .then will not be executed until it's done. And other basic promises, if you remember, is that it's not just the .then, but you can also add a .error or .catch, sorry. Yeah. And the .catch is the part that's called if there's an error. So, and when I say error, what I mean is like anything basically other than 200 code. So, or, no, I mean it's 400. As in like, no, not the 200 code. Like I'll show you, I think if you call like, if you just put gibberish in here, like blah, 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 it's probably gonna... Nope, it still did that. There you go. Well, you can use, there are some errors that will get caught here. So some general errors, you could like catch them like this. So basic promises, I call fetch, it resolves, which calls this function with the data that was returned, and I console log out that data. And you can see that there's a whole bunch of stuff attached to this, which includes body and blah blah else. So let's actually go back to the API docs. So when I call off login, it says my responses will either be 200 success or 400 missing username password or 403 invalid username and password. So you can see here how the status here is 400, and the API docs actually tell us it's a 400 because we're missing the username and password. Okay, so let's add that username and password in. How does it want it? It wants it as a JSON body. Okay, so what's the body? So now I'm going to Google like fetch JavaScript add body, or I'll add JSON body, make it even better. Look at some code examples online. I can see a couple of things here, which is that it doesn't just say post for this one, but it also has headers. Headers are basically metadata associated with HTTP requests. So in this case, the headers are saying that it accepts JSON and the content we're sending is JSON. And then you can also see here that the body is, if we want to send a body of JSON, it says we can send it like this, where essentially we give the JSON.stringify function an object. So JSON.stringify is a built-in object to JavaScript, which will take in like a JSON compliant JavaScript object, like an object or a list, basically simple types, right? Numeric types, string types, dictionaries, /objects, lists, arrays, whatever. And it will convert it to JSON for me. In fact, I can show you this here. If I take a data structure like this, I'll just comment all this out for a sec. And I console log it. You'll see if I console log just the object, and then I console log the JSON stringified version of it. This is an actual JavaScript object, which is why the browser can kind of see it and interpret it and color coded, whereas this is a literal string. It's literally ASCII characters here. So we're converting a JavaScript object to JSON. What do we actually want to send it though? Well, it tells us in the API docs. It says we need to send a username and a password. So I might create like login body equals this. And what username and password am I going to use? Well, I'm going to go back to what we did at the start, which was opening up this editor where I could see the username and passwords of some users. So there's this one user called Sophia. So I'll say that's Sophia's username, and her password is cluttered. Okay. So I'm about passing this data now to the server when I call it. And I will do that by adding it here, because remember it was the json.stringify of the login body, like that. Refresh this page, and it worked. I mean, that was easier than I thought. So we got a response. 200 is okay. So 200 body is everything went fine, which is great news. Great news. And it happened because we told it was of JSON type, we sent it a JSON body, and we sent it the right details. Watch what happens if we send the wrong details. Sophia. It says 403, so now we've got a 403 error. And you can actually catch and deal with these errors, right? Like I'll show you, it's like you could say here, if data.status equals 403, or alert, incorrect login details. Else, if the status is 200, we know we did it right. We could say console log logged in, smiley face, like that. I'll leave that console log data there. So, incorrect login details. Incorrect login details. If I change it to the right stuff, logged in, right? So that's the server's giving this back. Now the next big question is, how do I get this body here? Right? Like I actually because if you look at the API docs, it says that it returns this token string, but where is that token string? So when you make these requests, all the contents return in the body. So now I'll say JavaScript fetch get body response. Using fetch. Yeah, I mean, you could read through this. I know where to look, obviously, but uploading a file, uploading multiple files, processing a text file line by line, checking the fetch was successful, supplying your own request object, response objects, that looks promising. Body, okay, both requests, blah, blah, blah. The body mixin defines the following methods to extract a body. That's what I want. These all return a promise that is eventually resolved with actual content. Okay, so I can, on the body object, I can access one of these methods which will give me something. Now I know that my response is in JSON because these APIs deal exclusively in JSON. So instead of, after this, I will simply say console.log data dot, it's either data.body.json or it's data.json. Let's try this out. I'm not sure, I genuinely don't know. Where's my page? Is that it? Yep. Data.body.json is not a function. Okay. Data.json. Okay, that seemed to work. One thing you'll notice though here is when I tried to print this out, in fact I could make this clearer by putting the JSON string in front of it. It says promise. Now that's because these docs were quite clear. These all return a promise that is eventually resolved with the actual content. So what this means is that the designers of this system said, you know what, taking an HTTP response body and turning it into JSON is a pretty non-trivial activity. It's not like turning 1 and 1 into 2. So I'm going to make it a promise to execute asynchronously. So to print this out, just like I did with the fetch, I go data.json, which will, which is, you know, it's basically, that returns a promise that's executed, and when that's resolved, I'd like to return a function with the result, and then I'll console log that result, like this. And there it is, there's my token, right there. Result, console log result.token. Bam. Smack right there. And you know what, let's just take this one crazy step further, and let's just on our page, just somewhere, I'll just put it like here, div ID equals token. You wouldn't do this because it makes no sense to store the token. But let's actually just print this out on the page so we can see it. So I'll say document.getElement by ID token dot inner text equals result.token. So we're manipulating the DOM here. Bam, there's our token sitting on the page for me. That's nice. Simple, 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 simple. And you'll also notice there's a slight lag at the start because it actually has to make the HTTP request and get a response. You know, because it needs that response to even do anything. So now we have our token. That's nice. I'm going to clean up this code, get rid of some other crap we don't want, like this. Cool. And you might be thinking, okay, this is all well and good, but how do I actually use this? Well, in reality, what you're going to be doing is actually, you know, building front-end components like this. You'll be like, username is input type equals text, ID equals username, password, input type equals, say, text, ID equals password. Then you might have a login button, like button ID equals login button, login, right? Because how you actually build a website is you have these three elements here, and instead of just hard coding some object like I've done here on line 13, when someone actually goes to JSON stringify the login body, you're actually more likely to extract that from the form inputs. Now, one thing you'll notice is this entire chunk of code here is executed on page load because it's not wrapped in a function or anything. And let's change that. So let's actually only execute this code when the login button at event listener click. So I only want to execute this fetch code when the login button is clicked. And in fact, we can do that right now. If I reload this page, there's my form. The username and password are still hard-coded, but if I click login, the token appears, right? Because it makes the request. And you can see this in the network tab as well. Watch this. Page loads. Watch for the next line here. Login, click. It did two fetches. I don't really know what the other one is, but that's okay. Sure, there's a simple explanation. So I've got that there. Login and then huzzah. Now it's actually extracted from these fields. So rather than hard coding in login body, right? Because you know how here I just kind of hard coded it. Let's actually say, you know what? Login body. The username is actually going to be document.getElement by ID username dot value, and then the password is just going to be password dot value, like that. So now we're actually using our page dynamically. I refresh here. Username Hayden. Password is Hayden. I click login. I get an alert. Incorrect login details. I type in Sophia. I type in cluttered. Now I have a token. And I can do something with this token. I can go and make other API calls with this token if I'd like to. The last thing I want to show you is this idea of single page apps. And I'll just give you a really trivial example of a single page app. I'm going to make a div here called login screen. And then I'm going to make another div here called dashboard. Like this. Now inside the login screen, I'm going to actually put the login form, which makes sense. And inside the dashboard, I'm going to put a token, like a little div with the token. Now the way single page apps work is everything you do on the app is always the same page. It just happens that you're like toggling what's visible, you're generating, sometimes you can toggle what's visible, sometimes you can use JavaScript to completely add and remove things. But I'll just give you an example here, and I'm going to use an inline style, which you should not do, but I'm just showing you because I'm lazy tonight. Just display none. So I'm going to hide that little area. And I'll also make the background different colors just so, again, you can like really see the difference. So I'll make this one's background red and this one's background blue. Right, so the red is here because, you know, Red's a bit horrible. Yellow. The yellow's here because that's the form, and what I want it to do is when I'm logged in, I want to like hide the input form and show the dashboard instead, and I'll put some text here. Welcome to the dashboard, and I'll make that an H2 like this. Welcome to the dashboard, and then if they have to log in, I'll say please log in. So they're gonna get the please log in. They type in their details, Sophia and cluttered, and then nothing happened now. Why did nothing happen? Because my code did actually populate the inner text of the token div, but this is all hidden right now. So what I'd actually like to do is when I get the result, I don't just want to populate that token div. I would also like to go get my login screen. I might call this one dashboard screen. I like to go get my login screen, and set its style.display to be equal to none. I'd like to hide it. And I want to get my dashboard screen, and I want to set its value to block. Basically make it visible again. So I type in Hayden, get an error. I type in Sophia and cluttered, I get the page. Now see how this feels like this feels like a website. Like you click something, you get sent to another page, you get sent to another page. But this is what a single page application is. All of this is happening in a single HTML page with a lot of JavaScript. And it makes it a lot more fluid, a lot more natural. It just generally has a better quality of application. So now we're actually logged in, and I could do more things here. Now, I won't lie, I got through this coding example a little bit quicker than I thought. I thought we'd probably run till like 750 with this. This is about as much as I think I feel comfortable demonstrating to you, because like, you know, I'm basically giving you code to write the assignment with, but I don't want to give like you too much, because there's obviously a lot for you to learn here and try it yourself. But before we get into the marking criteria in the last 5 to 8 minutes of the assignment spec, does anyone have any questions? Because we can keep talking through the code, or if there are any auxiliary questions, we can chat about that. Valkanat says, are there alternative methods to then in implementing a response like so? There are some more modern techniques, but the problem is they're not really widely adapted yet, and there's a great deal of legacy code even at large companies that uses this format still. And there's actually things this format can do that you can't do with modern methods. So the short answer is like, this is still generally, while a little bit more difficult to work with, considered a vital skill, and probably will be for at least another 5 years, I'd say. So, you know, this is how promises work. Promises will be confusing. It is confusing. So if you find it confusing, be like, all right, well, I was told this will be confusing. I just have to keep doing it, and it will slowly click. And I'll have interesting questions to ask my tutors and help sessions and other things. Garo says, in the spec, well, we'll talk about that as we go through the last bits, if that's okay. Because that's the last bit to talk through. Just seeing if there's any last coding questions about stuff we've done, or the API or anything like that. Okay, cool. Let's move on then. So assignment 2, let's look at section 4. Section 4, constraints and assumptions. First thing is, you must implement this assignment in ES6 compliant vanilla JavaScript. Don't worry about that ES6 compliant thing if you're like, oh god, what is that? It's like, we're basically just saying you can't you can't use frameworks, you can't use super fancy things. The standard JavaScript is like ES6. You cannot use React.js, jQuery, or other abstract frameworks. You cannot, for example, use the popular JavaScript framework of Angular React. Okay, so you can't use frameworks, you have to use vanilla.js. That's okay. Most people get that. Browser compatibility, same as assignment 1. Use a modern version of Chrome. These versions might be out of date. I think I just realized I may not have updated those now that I read it again. For instance, my version of Chrome here is 88. Basically, we're just like, we're going to test your stuff on the latest stable version of Chrome. So make sure you test your stuff on the latest stable version of Chrome. 89, they're all kind of the same. That's honestly there as a blanket statement, so that when someone like does their assignment and tests it on like Safari version 3 years ago and they get all these weird things, they can't say, well, it looked fine on my computer. So don't overthink this. This is just like, you know, check it on Chrome. We've got this section on external libraries. You may use small amounts of code you find online. When we say use small amounts of code, none of this here requires attribution, because these are just you learning how to use a library. Like, I've copied code from the internet, right? But it's like 1 or 2 lines of code, and it's not unique code. It's not like someone has put in creative effort to generate it. I'm literally just copying from like docs and some doc examples. You know, code that you would need to reference might be something like, you know, a 5 or 6 line piece that does some DOM manipulation or has some CSS animations or something like that. You can include external CSS libraries. I think there's a lecture on that. Using CSS frameworks. Bootstrap's very common. Material UI is very common. Some of the libraries like Bootstrap will ask you to actually like install, like include a link to jQuery to have like jQuery used on the page, because some of these frameworks like kind of use jQuery. You're allowed to do that. That's one thing we allow you to do. So, you know, even though we ban jQuery, it's like you can't actually write jQuery code, but there's some other code like CSS code that will want you to import some jQuery. And then the last line, which was Carol's question, you may not directly use external JavaScript. Do not use npm except to install the helper development libraries. So what we mean by that is pretty much 99% of you aren't going to use npm or anything fancy for this assignment. You're going to do exactly what I just did today, except you're going to do more and more and more and more and more of it. There are some students out there that really like to, who have some experience with this stuff, who want to do things like install linters, or some other kinds of checks, or various libraries. And what we're saying is that if you want to go down the npm route, we're only comfortable with using npm to actually like do development, like linters, for instance. We're not comfortable with using npm to like, you know, use React or use some kind of CSS precompiler or anything else like that. The short answer is you aren't allowed to use external JavaScript or npm. The only exception is if you want to use npm to like add some dev dependencies. But again, if you don't know what that means, that probably doesn't concern you. And it's not even gonna, there wouldn't be much you could do that would even add that much help. The specification is intentionally vague to allow you to build front-end components however you think are visually appropriate. They're all up to you. So students kind of sometimes say things like, show likes, allow a user to see a list of all users who've liked a post. Like, I don't know what that should look like. And it's like, that's fine. Like, we want to give you some room to be creative, you know, like you're trying to learn front-end. We don't want to just like give you images of what to do all the time. And when we mark you, in the largest sense, in the broader sense, when we give you most of your marks, we will mark you to the criteria. Like, we'll be like, okay, well, we asked you to allow a user to see a list of all users who liked the post. Can we see a list of all users who liked the post on your site? Yes, we can. There's the mark. That's pretty simple. So don't be too stressed out by like if some things feel too vague. Like we specify things as much as we need to, and then we give you room to play around with it. There are some very small marks for user design and visual layout, but this is not a design assignment. You can get virtually nearly full marks, or like 90+%, having like a butt ugly website that's still usable. So you don't have to be a designer to get 100% in this at all. There is a lecture that's already been out on UI UX from Sparky. That will give you enough tips to kind of at least try and fill in that gap there. Just jumping to 4.6, await and async, which are the asynchronous shorthand functions, they're absolutely banned in this assignment. You can't use them. You will lose a large quantity of marks if you use them in the assignment. You need to use raw promises. And then last one is static HTML, inner HTML, and DOM manipulation. So as you've seen me do already, part of what you're doing in this assignment is manipulating the DOM, right? Now you're allowed to add as much static HTML to your HTML file as you want, like I've done here. I've kind of made these elements, I've written them out in HTML, and I've just like toggled whether they're visible or not. We don't expect everything you do to be creating DOM elements from scratch. That's just tiring. So you will create some DOM elements from scratch. In other cases, you will create elements that are hidden, or you'll create templates that you can copy. Point is, you can add as much as you want to this one HTML file. Totally up to you. Yep. One thing we're not comfortable with using though is the inner HTML property. And what the inner HTML property is if you haven't used it already, it's basically you can just say like inside the token is actually going to be like a bold, italics, hello, something like this. It allows you to inject HTML via a string. And this has some security vulnerabilities and stability vulnerabilities with it. So that's not an approach we want to see taken in the assignment at all. Most of you would have not done anything like that, so it's not a concern, but some of you might have dabbled in that and been like, oh, this is convenient. It's convenient sometimes, but it's not really good practice. So we pretty much just prohibit that as well. And then you got your standard 6, 7, 8, these sections are pretty normal. Patrick says, what if it's used in assignment 1? I don't know. I mean, like it's prohibited from being used. So like if we prohibit you from using something, like we reserve the right to give you 0 in the assignment. If someone used it, we probably wouldn't give them 0, but I don't know what we'd give them. But my point is like, you don't want to end up in that boat when it's totally preventable. So don't do that. And then in terms of marking criteria, so the marking criteria is out of 100, sorry. And yeah, so the marking criteria is out of 100. 70% of your marks come from sections 2.1 to 2.7, right? Which is essentially specifying all of the things you have to do: registration and login, the basic feed, the advanced feed, the user profiles, the updating content, the challenge components, and the very challenge components, right? That, I believe, is where 70% of the mark comes from. So you just have to kind of tick off those boxes and you're good. 15% of the assignment comes from mobile responsiveness, basically how usable is your website on desktop sizes, which are about, like 1080p sizes, tablet sizes, which like there's no hard and fast rule with this, because like tablet sizes are kind of sizes like that big. It's how big a tablet is, it's something like that. And then mobile sizes are going to be like what we've done in the labs and stuff, which are like this big, right? The specific size does not matter, like, because if we give you a specific size, it kind of implies that if it works at 410 pixels and not at 420 that you've passed. But it's like your site should generally be responsive. And we'll just check it on those general sizes. So that's where 15% of your marks come from, is how like responsive to mobile, you're responsive to different sizes your application is. Code style 10%, your tutor will look through your code. They'll look for standard things like, lack of repetition, using the right methods that we've talked about in the course. Not really any different to assignment 1. It's a small amount of marks just to discourage people from being reckless and being like kind of super messy, like people who maybe like would just copy and paste like would copy and paste this entire chunk for every single HTTP request they do instead of breaking things into functions, right? Like that's what that 10% is there to disincentivize people. And then there's 5% of the assignment, which will be much bigger in assignment 3, which is for like, is your application usable? Does it follow UI UX principles? Is it accessible? And this is a mixture of 3 things, which is, does your application follow common sense usability practices? Like, can a normal person use it and not be confused as to what to do and struggle to find things? Has it applied what it can from Sparky's UI UX lecture? Has it applied what it can from Mike's perceivability lecture? That's what that's for. On top of this 100%, there is also a 5% bonus mark section here where basically we say if you think you can do something creative and interesting and exciting that makes yours stand out, then you can do it. You can add information about it to the bonus.markdown file here. You can just like describe it, like as in, tell us about what the feature is so the tutor's actually aware of it. And then we'll give you potentially up to 5% extra bonus marks. If you're already getting 100% in the assignment, then that will bleed into the other assignment marks, not the final exam. And the other thing just to note about the bonus marks is that I'm going to get this question again, which is how much is enough to do for the bonus marks? The whole point of the bonus marks is to be non-prescriptive. The whole point of it is so that that you actually have some space where we're told do something you think is cool if you want to, and we'll give you some marks for it. But some words of advice I'd give you about the bonus marks. These should be some of the last marks you get in the course. And what I mean by that is if you're tackling the bonus marks section before you finish 2.1, 0.2, 0.3, 0.4, 0.5, and 0.6, you are absolutely wasting your time, because like your mark per time input of like nailing and getting perfect like everything in this assignment except for probably these 2 sections is just going to be so much better. Do you know what I mean? So like, again, like when students email me and they're like, I'm really stressed because I don't know how much to do for bonus marks, the first question I always ask is, do you think you've already gotten 90% in this? Like, first thing to check, like, have you nailed all the mobile responsiveness? Have you like put in accessibility things? Have you like gotten all these features out? And if their answer is not yes, then it's like, well, I mean, they can do it anyway, but my encouragement is like, if you care about your time, you're not spending it wisely yet. So that's usually where to start. Now, Voknuts asked, how intensive would you say the challenge components are, respectively, if I could give some points of reference? That's a great point. So I think that 2.1 all the way through to 2.5, right? I think most of this is pretty similar in terms of I don't think that you'll feel a ramp up through these 5. It'll just feel like more work to do. I think the stuff in 2.6 will start to feel maybe like 2 or 3 times harder than the stuff before it. And then the stuff in 2.7 will start to feel two to 5 times harder than like the 2.1 to 2.5 stuff. That's probably the best reference I'd give. I wrote advanced times equals 2 here. I think I meant by that it's probably twice as hard as advanced. Yeah, like these are advanced. These are like twice as hard. So, and these are worth 15%, right? So the whole purpose of this is that a generally competent student who goes and does all of the 2.1 to 2.5, they do the mobile stuff, they do the usability stuff, they make sure their code's clean, HD. Right? If they nail it all without even looking at the challenge stuff or the bonus, that's an immediate HD, assuming they nail it, right? And then this stuff takes things further. One thing I just want to share with everyone, for anyone even in the recording who's stuck around this long, is that I've started to notice this problem with some of the courses I run because of the nature of the courses I run. This is a practical course, right? This is not a theoretical course. This is like you get in and then you do the stuff and you make it. And one of the problems I've noticed is that like in a course like a maths course or something, or like engineering mechanics, you get asked a question, right? Like, what's the rotational velocity of so-and-so? And you answer the questions. And there's this relationship that happens in these courses whereby if you get posed with a set of problems, you can actually successfully attempt and complete all of the problems, but you could still get a lot of it wrong, right? So there's this kind of disparity between what you can finish and what you do right. One of the things that happens in these practical courses I've noticed is that because it's so well prescribed what we want you to do, like 90% of the time, there's a little bit of vagueness here and a little bit of vagueness there, but it's like, it's pretty clear. It's like users can upload and post new content from a modal or separate page. It's like your tutor's going to mark you and be like, did they allow the upload and post of new content from a modal on a separate page? There's this strange relationship in practical courses where the act of finishing something is pretty much the same as getting the marks, if that makes sense. And this creates a very strange dynamic I've noticed in the last year or so with students where some people are kind of hardwired because of educational experiences they've had to get used to finishing everything, right? If they get presented with an assignment, they're like, my default response is to finish it. Because in other courses, everyone can finish it, but everyone's marks are wildly different. Whereas in a course like this, the act of finishing it kind of correlates pretty heavily to marks. So what I'm getting at this is that don't be dissuaded or disillusioned or upset or feel like the world's against you if you actually don't do 15% of the assignment. Because that's kind of normal. Because if all of you finish the assignment, all of you are probably getting very high marks, which means that we haven't done assignments properly. So I hope I'm making sense with all of this. I think it's an interesting topic, which is just like, the challenge is in finishing it, not in getting it right. Because in finishing it, you basically get it right. So just keep that in mind for those of you who kind of get squeamish, because it's like, we design this in a way that we expect, in theory, there will be more people that do it than this, but we expect 85% of students, in theory, to not do 2.6 and 2.7. More than 15% of you will do it, but there's like a joke I used to make with students, which was like, do you think you're in the top half of the students in this course? And if the answer is no, then I don't know why you'd put pressure on yourself for doing this. You know what I mean? Like, it's like they're like this. Like when I say that, I just mean like, some of you have more time and more intellect and various other things, but it's just like this, like, it's like the whole thing is not designed for everyone to finish. Okay. And it's not because we like to create challenging problems. We're like, no one can finish it because that's, we're like those people who hate giving 20 out of 20s. It's just finishing it is getting it right most of the time. So that's why it's long, because the only other alternatives we give you all 100%. Yeah, James says auto marking that requires finishing is very stressful, especially when it's not broken down into sections. Yeah, that's why we that's why we try and do it this way too, so you can check it off in your head. Anyway, I'm pretty much at the end now. There was a question that Volknut asked before, which was, when catching or dealing with errors, are we being given server-side error codes, or are there some that would be client-side too? That's a good question. So you're going to get error codes from the server like this. Generally, we don't really expect you to pass them on to the user. You can if you want. Like, actually, I don't even think they give these to you. So I don't actually think you get errors from you get server-side error codes because it's written in here. But like, basically, it's like, if you get a 409, then the front end just has to say username taken. But the thing again is like, I don't even think the specification specifically says, like, if they try to sign up with I don't even think it says if they try and sign up with a current username that it says like, was it? If there is an error during login, an appropriate error should appear on the screen. Okay, I maybe take that back. Like, I think that kind of pretty much clearly says like, if you try and call sign up, when this says login, it kind of means register. But if there's an error during the registration part, then an appropriate error, i.e. a relevant error, should be shown, which would in this case be like, if you get a 400, you could say, please check your username and password and try again. And if you get a 409, you could say, sorry, that username has already been taken. Like, that's the extent of it. And your tutors will literally just plug in Sophia and be like, yep, it said something logical. They'll plug in like the wrong password and be like, yep, it told me that I need to try again. That's it. Start this assignment early is my only advice to everyone. Mainly just because I saw a lot of students last term that, you know, it consumed them for the last 3 days of flex week. So start it early, tackle it in small chunks, you know, find the time in the next 2 nights to pull this out and try and emulate what I've done here in the lecture, and have a basic login dashboard and be like, oh, cool, little milestone. I'll come back to it on the weekend. All right, is there anything else? Otherwise, we'll wrap it up for today. Devansh, what did I mean by 60% of this course? Isn't the practical component worth 75? I don't remember saying 60%. Maybe I've forgotten. Can you just ask me another way? Might be helpful. And Volknut, just the separate page thing. Would it be giving away too much if you quickly went over what that meant? I'm also not sure what that... Is this in the spec? I feel like I'm getting dumber. I don't really understand either of your questions. And, 0.2.5.1. Okay. Oh, sure. I mean, in the spec, you'll see things that are like separate page. All that's really saying, like, anytime we're like separate page, we're kind of saying the appearance of a separate page. Like, it should feel like a separate page. Like, that's what I did here, right? Like, this felt like I loaded up a new page. But in actual fact, it's like, it just feels like a new page. But another way to do this is that the login is actually just like a pop-up on the dashboard. Also, the adding a post. So it's like when someone goes to add a post, they can either get like a modal, which is like a pop-up, like a box that hovers over everything, or they can get taken to a whole separate page to make a post. And when, again, anytime we say separate page, it's referring to it feels to the user like it's a separate page. Yeah. And then Devansh 2.8. Oh, sure. So the point is that sorry, I see what you're saying. Yeah, sorry. The assignments last term were only worth 60%. That's just an error on my part. Sorry. What was it? 60%? It should be 75. Yeah. And what was the other error we noticed, or I mentioned that I didn't change? Oh, it was like the quick pick thing, and it was something else, but maybe I forgot it. Chrome versions, thank you. A separate page is not new tab on the browser. When I say separate page, I'm referring to what we did here, where this feels like a separate page when I type in Sophia and cluttered, even though it's like a single page app. It feels like a separate. Sometimes we refer to them as screens. It feels like I just went to another page, right? Like if you were giving this to your like your grandparents or something, and you were like, click login and you'll get taken to another page. Like that's kind of what we mean. We don't literally mean a separate HTML file because we are building a single page application. Oh, did my camera disappear or something a while ago? Maybe my phone died. Huh. Yeah, it died. There you go. Strange. Cool. Sometimes that happens. Where's my camera? I've lost it. Oh well. Oh, there it is. It's hiding. down the bottom. Huh. Oh well. So strange. Okay, sorry, I missed some questions. Should the login button be used when you press enter? That's an example of like some good usability things. No, like your tutors would probably not expect that to happen. But you know, that's an example of like things that would improve your usability mark, or it's a really gray area. Generally, what I would encourage you all to build applications that you think are useful. You know, like I think when you build an application where you know, you're like when you type in a username and password and you press enter and nothing happens, that's kind of annoying. So I would just try and add that in because it's useful and it's good for my learning, and that's why you're here. That's a good Dom joke. Dom, get it? Not really. That's not even funny. Okay, let's wrap it up. It's 7:59. Any other questions? Let's chat about on the forum. There'll probably be some follow-ups next week that you'll all have. So let's chat then more. But this will probably be the last time we talk extensively about assignment 2. So anyway, thank you everyone. Hope you have a great evening, and look forward to the fact that you don't have an assignment due for. I don't even remember when I said it was due. Now I'm worried I gave the wrong due date. Oh, I made it due on Monday. That's very kind of me. Oh, it's because it's mid-break. Yeah, okay. This sucks because assessment 3 will be released on that day as well. But, you know, anyway. Sounds good. Thanks, everyone. Have a great night. Talk to you soon.